Hello students, welcome back. We completed all the theoretical stops for section 2. We went through the definition of the logarithmic function. It's an inverse function of the corresponding exponential function of the same base. And we went through the graphs of logarithmic functions. This is an important case. And then the natural logarithm when base is e. In that case, we abbreviate as ln. And of course, the logarithmic rules. Cancellation rule, that's something we are going to focus upon right now. And as for these rules, well, this one will go to full swing in module 13. For now, let's postpone this. And we may use a little bit of this one as well, change of base formula. But in any case, the important one is this one, how to use the cancellation rules. Okay, all right, let's begin. Example problem 1 here, exponential logarithmic equations. We have an exponential equation here. Does it look familiar to you? Well, let's go back to this problem here from the previous section. How about these? Do they look similar? Exponential equals to something. Exponential equals to something. Do they look similar? Let me copy and paste so that you can look at those in the same viewing window. Okay, these problems versus this one. Do they look similar? Similar, maybe, but actually no, they are fundamentally different. Here, we have the same base. This 81 downstairs here, that's 3 to the 4th power. So overall, we have 3 to the negative 4th power. And then we have the same base. So all you have to do is to compare the exponents. Same thing goes down here. We have 4, which is 2 to the 2nd power. So base is 2 for both. So here you can compare the exponents. Now let's go back to problem we have here. We have 2 different bases. Now how do we handle that? One way to handle that is to use the inverse function or the cancellation rule. See? They're coming from inverse functions, so inverse and original cancel each other out, no matter which order we have. So we have exponential here. If I take log of both, you're going to get cancellation through this. More precisely speaking, log base 2 of 2 to the 4x minus 1 power is equal to log base 2 of 3. If I do that, and this logarithm and this exponential will cancel each other out. Cancellation rule, they're inverse functions. So we have 4x minus 1 is equal to log base 2 of 3. And we just have a linear equation to solve. Don't be intimidated by this location here, this one here. And this is just a real number, a digit string. Nothing to worry about. Flip one to the other side. Flip 4 to the other side. And that's how you do it. A complete solution here. So the key is to take the inverse function to kill off this exponential. Okay, take the inverse function to kill off the exponential. Log base 2, the same base. How about the next problem here? This is a logarithmic equation, so it looks like you'll have to kill off the logarithm. So it's got to be this one, the first one. Exponential of log will cancel each other out. But then again, if you have log equals to something, yes, but this one is given in terms of some fraction, so you need a little bit more work. So how do you handle it? Try on your own. Have everybody tried by now? Well, here's the idea. Whenever you have some equations like this, remember the three-step process. Denominator is number 1, parentheses number 2, like terms number 3. Here, in this case, no like term. All you need is the denominator. Basically, you're going to get the denominator multiplied to both left-hand side and right-hand side. You're going to get this. Yes. Here, denominator is flipped over to the other side. You multiply. And then break out the parentheses by distributing around this 2. And then solve for this logarithm. Okay, 6, flip it over, minus 5. Or you can regard it as like terms, whatever term you want to use. And divide by 2, you're going to get negative 2/5. Negative 5/2 is equal to this logarithm. We got through. Log is equal to some number. Now what do? How do you remove the logarithm? By taking the inverse. So we're going to take the inverse function, the exponential of both sides. Here we go. Log is equal to negative 5/2, and we take the exponential of both sides. If we do that, exponential and log will cancel each other out. We just get x minus 3 like this. And to the right hand side, just e to the negative 5/2 power. Experienced students will just skip this and skip that one too, directly from here to there. And then flip this 3 over to the other side, we have the answer. So, we went through a couple of problems regarding the cancellation rules. So solve for exponential and take the log of both sides, or solve for the logarithm and take the exponential of both sides. That's how you can kill off the exponentials and logarithm. Okay, alright. Now we have some graph problems coming up. Plot a graph and determine all intercepts and asymptotes. Okay, first problem here. And kind of analogous problems are here when we had exponentials only, find all intercepts. But here we had the exponentials only, but this time exponential and logarithms put together. Okay, let me stop this recording here and get Desmos graphing calculator ready. Okay, I got it ready here. Okay. Compare, same function, and here's the graph. A little bit difficult to see, too much vertical stretching here. So, negative about 5 to about positive 10. Okay, alright, we have this kind of graph. Okay, alright. So what do we have? We have y-intercept here, x-intercept there, and then it looks like we have a vertical asymptote forming here. And that's about it, isn't it? No horizontal asymptote. So we are looking for those quantities. By the way, this is a graph from Mathematica, similar graph as before. We are looking for this y-intercept, this x-intercept, and this vertical asymptote. The easiest of the bunch is, of course, the y-intercept. Just plug in x equal to 0 and do your computation, and there you go. Any question here? Plug in x equal to 0 and then just run your calculator. By the way, you don't really have to run the calculator, but it's a good checking process. This is sufficient for full credit. Next, let's find the x-intercept right here. That's when the y-coordinate, the function value is 0, so the numerator is equal to 0. Okay? So how do you find out the x-intercept? Function is 0, function value is 0, so the numerator is equal to 0. Let me copy and paste this one. So we ended up with an exponential equation. How do you solve it? Try it. Stop the playback and try it. We can solve for exponential first. So flip this 5 to the other side, then -2 exponential of x minus 1 equal to -5. Okay. And then divide by this -2. So e to the x minus 1 is -5 over 2. No, positive 5 over 2. Negative, so it's positive. Okay, all right. And then, any idea? We have to find x. We have exponential is equal to 5/2. What do you do next? So here, and we take the inverse function. We take the natural logarithm of both left-hand side and right-hand side. That'll kill off this exponential. By the way, this natural logarithm, ln, is the same as log of base e. It's the same thing. This is just abbreviated notation. So they're going to cancel each other out. We can just get x minus 1. And log of 5/2, well, that's just a real number. So flip this one to the other side, and there you go. You don't really have to calculate and get this digit string if you don't really want to. But it's a good checking process. If you get this number, you can compare that with this graph, and it makes sense. So, solve for exponential and taking the logarithm. Now, find a vertical asymptote. Looks like we can set the denominator equal to 0. We have denominator 0, then that's when we have vertical asymptote. Denominator cannot be equal to 0, so y-coordinates will be pushed toward possible -infinity or both. So set the denominator equal to 0, which means 1 minus 4 log of x plus 3 equal to 0. Looks like we have to solve that equation. Too many spaces in between. And then how do you solve for this logarithm? Well, flip one to the other side. Plus 3 is equal to -1. And then divide by -4. Did everything all good? And then what do you do? I have to remove this logarithm. How do you do that? Here you go. That's what we did. And we can remove by taking the inverse function. Exponential and log will cancel each other out. So you're going to get just x plus 3. And the right-hand side is, of course, the exponential of the right-hand side. Experienced students will just skip this and go from here to there directly. And then flip 3 over to the other side, you have the answer. So, we wanted the y-intercept, x-intercept, and the vertical asymptote. We just found all those. And they all match the graph. But by the way, there's one more potential trouble. That's when logarithm have inside of the logarithm becomes 0, because log of 0 is -infinity, as you can see from this kind of graph. You see? Yeah, -infinity going down like that. So how do you handle that? In this case, it turned out okay, because if I plug in x equal to -3, so log of 0 here, so this logarithm is -infinity, so we ended up with something over infinity, and that's 0. You see, infinity in denominator, so no problem. So going down to 0 like that. So no problem, and this problem is complete. We're going to do the next problem in the